Hi, welcome back to AP Physics 1, Unit 3. This is the work energy power unit. So here we are on topic 3.5. So power is the culmination. Sometimes teachers will teach this after work because it has a more direct connection to work, but we don't. It's not WPE, right? We call it WEP, work energy power. All right, so power is the rate at which energy changes with respect to time. Here in AP Physics 1, you'll see in the last bullet point, we're going to really focus on instantaneous power, not average. We're gonna focus on average power, not instantaneous power. Okay, the average power is the amount of energy being transferred or converted divided by the time it took. So power average is the change in work over the change in time. Okay, but there is a string of equations that this also equals. Excuse me. So you end up with F delta X over delta T, right, when I substitute in work. But delta X over delta T is velocity, if you remember way back in Unit 1. And so another representation of power is FV cosine theta. But remember, this is the net force, right? Work is net force. Okay, not force it's the forces that are acting on the object. Okay. Now, when we look at this, instantaneous power delivered to an object by a component of a constant force parallel to the object's velocity can be described by the following equation, right? So I mean, basically just take away the deltas, right? You call it W over T. But again, in fact, sorry, this is the equation that should go here. I do apologize for that. So the unit for power is watts. Okay. And here in America, we have a more common unit for power, which is horsepower, which 1 HP is 746 watts. But a lot of times watts is such a small unit itself that they often will use the unit of kilowatts. So 1 kilowatt is 1,000 watts. You should see this unit if you do electricity and magnetism in AP Physics C, because this is also electrical power where they give us the wattage for light bulbs, right? 60 watt, now they got like 7 watt, 23 watt light bulbs. Okay. So again, that's the amount of energy transferred. That's the electrical energy transferred over time. All right, so let's look at an example problem. Okay. So here we have a 10 kilogram block attached to a light cord that is wrapped around a pulley by an electric motor, as shown above. At what rate is the motor doing work when it is pulling the block upward with an instantaneous speed of 3 meters per second and an upward velocity of 2 meters per second squared? So the first thing we need to do is figure out, right, what is the net force acting on said object? So we have the tension up, we have the weight down, okay? And so we just do T. So it's going to accelerate upwards. So we'll call tension positive, weight negative. And essentially we're finding the tension, but that ends up being kind of the force we're looking at, right? That is the force that is creating what is happening, right? And so we do tension is mass times G plus A. So it's going to be 10 times 9.8 plus 2. Okay. So you end up with, I think it's 118 newtons. Yes. So the force, right, that is pulling up is 118 newtons. Okay, so that's what we need to use to figure out the power created by this motor. So we're going to use the equation FV cosine theta. But again, motion and force are going to be in the same direction. So this is essentially going to be 1. So power is F times V. So we're going to do 118 newtons times 3 meters per second, and we end up with 354, sorry, not newtons, but watts. Now, if you wanted to convert this to horsepower, you just simply do 354, can't write today, so 354 watts, right? 1 HP is 746 watts. And so you just simply divide 354 by 746, and you get that this is a 0.47 horsepower motor, right? This is what they would look for here in science, but if you want to relate it back to, just here in America, the ratings of our motors are in horsepowers. So if you have a pool filter or pool pump, you're going to see it's a 1 horsepower, half horsepower, 1.5 horsepower. This could be, this is we're pulling up a 10 kilogram object. You can also use this as an elevator scenario. Okay, they're going to be a little bit more rated. Cars are rated in horsepower, right? So like the Mustang 500 Boss, that's a 500 horsepower engine. Okay, and the reason why we call it horsepower is because it's the amount of power generated by a set number of horses, because the engines, remember, replaced the horses. Hence the reason why in the previous slide I have these horses, right, in our picture, because that is what was being replaced by engines. Okay, so this is the end of Unit 3. Unit 4 is going to be momentum, or linear momentum specifically, and we'll get into some energy kind of conversations there as well. But again, looking forward to continue your journey here in AP Physics 1.